possible for us to be here right now together, miles away from land, yet completely plugged into the world. So in other words, we are going to talk about how we connect and how that is all still a very magical thing. So to understand how we got here, we're going to have to understand what the world was like before Marconi. Now, for most of history, communication was limited by how far and how fast your means of transportation could go. People hiked through snowy mountain passes, ran marathons, tied notes to balloons, and employed whatever animal helpers were available. Ponies, mules, dogs, carrier pigeons, even sheep. Messages, I know, isn't that cute? Messages, they could take days, weeks, months even. That is, unless, of course, your sheep got confused and wandered off to join a random flock in New Zealand. I miss you, Daisy. I still need to get that letter to Grandma. Anyways, in the 19th century, things got better with trains and ships, but it still took a long time to get a message across the expanse, because your world was essentially as far as you can see. And around the middle of the century, this guy came along. You might have heard of him, Samuel Morse. Now Morse, he was an acclaimed painter from Boston. He studied in Europe, founded an art academy in New York, which is not too shabby. Later in his life, he became interested in this newfangled thing that everybody was talking about, electricity. As you probably guessed, he went on to invent a telegraph system and a code that is named after him. So, talk about a very productive midlife crisis. Now, some people buy a sports car, and some people invent a language for instantaneous communication. And both are actually just fine. Now, Morse code, what it does, it translated the alphabet into dots and dashes. Using these two signals, a short one, a dot, and a long one, a dash, as well as perfectly timed pauses, people could communicate complex messages. So I want you to remember how Kate telegraphed, "I love you," to Romy. Well, to do that, she would translate each letter into a message into the Morse equivalent. Now, I is 2 dots used in the International Morse code. Then there'd be 7 units of Morse code silence to mark the space between the words. Then you'd have an L, 1 dot, 1 dash, 2 dots, O, 3 dashes, and so forth. By the way, the silences between the words and the letters, well, they are milliseconds long. So you can imagine how much skill it took to be a telegraph operator to send and receive messages quickly. Now, Morse code was very simple, but it was also very sophisticated. It became the standard everywhere, including on ships. Now, officers on ships used what's called an Aldis lamp to communicate with Morse code. So instead of tapping out dots and dashes, they would just flash the Aldis lamp at the right intervals. By the way, that spells out our initials, HAL, Holland America Line. Now, someone on the receiving ship would watch with binoculars, and all of a sudden, with this new language and new technology, people could communicate easily across distance. Now, an Aldis lamp is fine if you're at sea, but what if you want to communicate really far away? Well, that's where electricity comes in. So remember when you were a kid and someone showed you a tin can telephone? Now you have 2 tin cans connected by a string. You can talk into one can and the sound travels through the string into the other can. Well, telegraphs kind of works like that, except Morse didn't use string. He used wires. Instead of sound, he used electrical impulses or pulses. Now, electricity travels really far and really fast, especially when it travels through something called copper. Suddenly, overhead wires went up in cities all around the world. Even the Atlantic Ocean was wired with a 2,300 nautical mile long underwater cable. Now that's 3,700 kilometers. Here's Tom Lewis. Now, he's a professor at Skidmore College, and he wrote a book called Empire of the Air.
So all of a sudden, the world becomes much smaller, very much smaller, because electricity moves at the speed of light, and that means that that signal sent from England or from Europe is virtually instantaneous to be received in New York or Philadelphia or Boston.
So can you imagine how revolutionary this was? A message that would have taken weeks to be sent, and just like that. Being connected by wires had some downsides though. For one, it was extremely expensive. Copper wire doesn't exactly grow on trees. And telegram companies, well, they charged a lot for the right to use their telegraphs. By the way, just to clarify, telegram, that's the message. Telegraph, that's the actual device. So some people estimated that it would have taken like an average skilled worker to work 1 or 2 days in order to afford the cost to send just one word across the Atlantic Ocean. So it wasn't accessible for everyone. And then there's an issue of privacy. So I know you probably know people who get freaked out about whether or not your text messages can be read by someone else. Well, you have no idea how much better it is now than it was back then. Telegrams over land or sea were sent through the post office or a private service. So one person had to read your message and turn it into Morse code. Then there's a second person had to read it again and turn it back into natural language. So yes, no secrets via telegram. That is, unless you want your mailman to know. Now, of course, there were places where wires couldn't go, like ships. So can you imagine sailing through the ocean with a giant leash attached to the ship? Now, if that cable is just 10 feet too short, we're not getting into port. So wire communications, it definitely had its limitations, but this was the 19th century. It was a time of discovery. People were learning more and more about how the world worked. They were breaking new scientific ground, and they were making a lot of new things. The telegraph, the telephone, the phonograph, the light bulb, the automobile. Even blue jeans were like 15 minutes old. So we think of the iPhone as a big deal, but can you imagine going from candlelight and ponies delivering mail to cars on electricity? It is actually during this time that Marconi is born, right on the cusp of modernity. So who was Marconi? Well, for starters, he was part Harry Houdini, part Alexander Graham Bell, and part P.T. Barnum. He's part of the story of the Titanic, actually. And he's the reason why you're able to text your best friend. Now, Marconi was born in Bologna, Italy. His father was a businessman, and his mother was an opera singer and an heiress to the Jameson whiskey empire. So you have to picture this. You got young Marconi. He lives in a stunning mansion in the heart of Italy. He's surrounded by wealth and fancy people, and he grew up with all these discoveries happening all around him. So he falls in love with science and electricity from a very young age. Now here's Barbara Dugan. She is a retired education specialist at the National Park Service.
As he got older, he learned more and more science, and he started connecting pieces together. He went to the Alps with his family, and while he was there, he read a magazine about Heinrich Hertz's experiments, and that was his big aha moment.
Okay, so Heinrich Hertz was a physics professor in Germany, and he was curious about electricity. Now, people knew that electricity could move through things like water and wires, but there was actually a new theory going around. What if electricity could travel through the air? And Hertz, the intrepid physicist that he was, well, he decided to test this theory. He experimented with creating electrical shocks, but instead of funneling the electricity through a wire, he actually made it jump through the air. So I want you to picture this. This is an experiment that he tried. So he's got a dead frog on a lab table and an electrical generator right next to it. He creates an electrical wave that travels across the room, shocking the dead frog's leg. The leg moves as if by magic. And if that isn't the perfect Frankenstein It's Alive moment, I don't know what is. That's all well and good, except the dead frog leg thing actually didn't work. But Hertz did manage to send an electricity pulse through the air. Now it was a huge deal. Because back in Marconi's day, people had a sense that something kind of was out there floating around, but they had no idea how it worked.
In the older days, I think people called the atmosphere the ether, because they knew something's around us, but we don't quite know what's in it. So it's a mystery. It's like walking through a blob,
Now, Hertz was the first to break through the blob and send electricity. But when Marconi read about this experiment, something kind of clicked in him. He wondered what else could travel through the air as if by magic. What if he could send a telegram without wires? So, remember back to those tin cans. Electricity traveled along the string. Now, Albert Einstein once described it like this. The wireless telegraph is not difficult to understand. The ordinary telegraph is like a very long cat. You pull the tail in New York and it meows in Los Angeles. Exactly, cats. So the wireless is the same, only without the cat. So thank you, Albert Einstein. We all got it right. Now there's no cat at the end, and I hope you all enjoy this talk. Goodbye. No, seriously, we're going on with this. This can actually be kind of a hard thing to wrap your mind around, but I'm going to explain it. So the kind of energy that Hertz generated is called an electromagnetic wave. And even though they're literally electricity, they aren't that different from water waves.
One of the best ways to describe an electromagnetic wave is to think about dropping a stone in a calm and quiet pool. You'll see the waves ripple out. First, they're rather large waves, then as they go further and further from the stone, they become smaller waves, and they lengthen out, and they become weaker waves.
So right, but instead of using water as the medium, electromagnetic waves, they travel through space, as in the stuff that's to the right, to your left, and in front of you, and all around you. We are swimming in electromagnetic waves. Some of them, they're visible, like light waves. But other electromagnetic waves are invisible, and they can travel far through wells and even through us. Now Hertz, he figured out how to send a wave through space. But Marconi, he actually wanted to figure out how to catch that wave and turn it into something useful. Now back in Marconi's day, no one knew if that was even possible. But Marconi, well, he wanted to try. And so what he did is he took Hertz's experiment outside, and instead of sending a wave from one end of the room to another, he sent it yards away. And he didn't just send a random wave. He actually sent the letter S, 3 taps in Morse code. So in other words, he actually sent a message. And unlike Hertz and other formally trained scientists, Marconi, he immediately knew that this could be valuable. He wanted to make practical use of these waves for the greatest benefit of mankind. And for him, that was all about bringing us all closer to each other. Now, he became obsessed with this idea, so he repeated the experiment over and over and over again, perfecting his device and pushing the distance farther and farther.
His mother and father would be concerned that he spent hours and hours, never coming out of the family attic because he was up there tinkering, changing filaments just to see that it would make a difference.
So, he finally had a product. On one end, there's a transmitter that broadcasts the radio waves. That's hooked up also to a telegraph key. Now on the other end, he actually needed something that would receive the waves and decipher what was sent in them. So he set up an antenna that picked up on the waves and attached a small device called a coherer. Now it looks like a test tube, and it contained metal fillings. So when a wave hit the antenna, the fillings would come together and the electric wave would get turned into a dot or a dash for Morse code. So in other words, he essentially got rid of the cat.
Marconi gets the nickname the Wizard of Wireless, and he has a black magic box. And when he brings his actual devices to England from Italy, they get broken apart by, I think, the customs officer, because they don't trust what's inside. Who was this crazy Italian guy? You know, they didn't understand what he was doing. And who would at that time? Who could think that words could fly through the air?
Groundbreaking new technology, but that's not enough. Now he's got to sell it.
The other part of Marconi's genius, that he understood better than anyone that it was not only the discovery and the invention, but it was the promotion of the invention that would make it pay off. He then promotes his invention by demonstrating it to princes and kings across Europe. Each one of these events was a miniature moon landing. This was an exciting thing. They knew the world was changing. They understood it was profound.
Now these weren't just demonstrations of science. Now this is where the Houdini and the P.T. Barnum thing comes into place. These were practically magic shows. People went to Marconi's demonstrations in 1912. The Titanic's queue of messages was actually full. People were sending and receiving all kinds of messages wirelessly. A silly joke, well wishes, you never believe how big and beautiful this ship is kind of thing. And the Titanic's operators, well, they spent hours going through the backlog. They were so overwhelmed that they ignored some messages about icebergs, including a message from a Holland America Line ship, the Noordam. And we all know what happened next. At 11:40 p.m., the Titanic hit a large iceberg. Suddenly, the wireless operators frantically started sending out SOS signals. Now, the Titanic's sister ship, the Olympic, received the message but was 500 miles away. The closest ship, the Californian, didn't get the message because they only had one wireless operator on board, and he had already gone to bed. It was only by chance that the operator on the Carpathia noticed that the Titanic wasn't receiving messages. So he telegraphed the Titanic just to let them know about the queue of messages in line. Now the Titanic, they responded immediately. Now it emits radio waves that travel out across the sea. And when the waves hit something, they deliver the information about the object back to our officers. Now radar, it can pick up anything from speeding cars to raindrops. And if two ships are close by, they would pick up each other's radar signals and know to steer clear of each other's way. Now without radar, like on Laura's trip, ships might not be able to see each other, and obviously that can be really dangerous. So in other words, radar, it helps us see what is otherwise invisible. Marconi's influence goes far beyond radar. It is actually all over our bridge.
So this is one of our radar screens, so you can see that it starts to pick up a picture of what's around us. Right next to us here, our VHF radio, which is the radio we mainly use to do any communications. So currently it's on channel 14, which is the channel that we use to talk to the port. We've got our echo sounders. Echo sounders generally used by sending electromagnetic waves down, and so they'll bounce off the seabed and they'll give us an image of what's below us.
And it's not just the systems that our officers use. Radio waves are the reason we can stay connected to the world ashore. It's also why you can check the weather while lounging up in the Lido deck, or watch a sports broadcast at one of the ship's bars. And also, you can email a friend before you go to sleep in your cabin. You can see this technology working all around the ship.
Out here on the sky deck, you can see that we've got all these domes around us, and they are all satellites. So all the big domes, you see those, they are all linking to satellites. This one is most probably going to be talking to the television sets, and then these ones will be Wi-Fi, satellite reception, Iridium phones, anything like that. They will be getting all our satellite connection for that. This one specifically, you can see it's a C-Mobile. So if you're using your phone, that will go straight up into space, contact any of the satellites. Sometimes you can see them at night time, it's quite cool. And then it will come straight back down, and it will reach whoever you're trying to contact at home.
It is really amazing just how much we actually really rely on radio waves, both on and off the ship. Now, they have helped us heat up food in under a minute. They've helped us talk to someone on the other side of the world, and even NASA uses radio waves to communicate with the space station far above our planet. Now, all of this is great and convenient, and it has also made our lives so much better. But the whole point of this technology isn't fancy satellites and crazy gadgets. It is all about how we connect and the amazing things that we can achieve together when we're able to reach out and communicate. And that's why with all this stuff at our fingertips, we still have technology that predates Marconi on board every single one of our ships. Take, for example, we still use flags to communicate.
So these three flags we use quite often. So we have flag Alpha here. That means that we have a diver down. So telling other vessels, please be careful around us. We have divers in the water. Bravo, saying that we're taking on, discharging, or carrying dangerous goods. So the only time we would use this is if we're bunkering fuel oil. And then Quebec, so that's the yellow flag here.
Now the Quebec flag is used to communicate with the harbor authorities. So when we fly this flag, we're asking for what's called free pratique, which means we're formally requesting that the harbor authorities allow us to start our port operations. And when we arrive at port, we actually fly 4 flags. We have the Quebec flag, the Dutch flag, the flag of the country we're visiting, and a Holland America Line flag. So the next time we're sailing into port, take a look up at our bow. And now you know what all those flags mean and be a part of a centuries-old means of communication that we still communicate today. Now we also communicate with lights. Every single ship in the world has a red light on its port side and a green light on the starboard.
So at night time, this entire bridge is completely black, which means if we're sailing along, we need to be able to see lights out there and determine what they're doing. So if I see a red light, then I know I'm seeing a port side of a ship. If I'm seeing it on my starboard side, I know he's going to cross me and I need to take action. So that is the way of communication that we use.
So ships often use short blasts or horns to announce where they're going. Now, if we're leaving port, you will hear 3 short blasts. Now that means we're moving astern or backwards. 1 short blast means we're going starboard. 2 short blasts means that we're going to port. Now, because we're on a cruise ship, and a lot of people, and a lot of you, are sleeping, we tend to stick to the Aldous lamp at night.
This is our Aldous lamp. If we have a situation where we've got a vessel on our port side, for instance, who's not altering course, then technically as per the rules, we should, instead of using the radio, we should use sound and light signals to illustrate that we're concerned. So in this situation, we would do 5 short, so you would literally just go 1, 2, 3, 4, 5. And if they see that, they should be like, oh, they're not happy, I need to alter course, and then go from there. So it's even got a little sight, so you can look through and actually specifically go, that is the ship I want to flash at.
Now, my favorite analog communication device, though, is something that we actually don't use anymore.
So this is actually a telegraph that's from our original New Amsterdam, so the very first one that ever came out. We're number 4 at the moment, the 4th New Amsterdam, but this is from the first one. And this is a way that the bridge used to be able to talk to the engine room on what they needed. So if they needed to go full ahead, they needed to go slow ahead, if they needed to go astern. And this was just how they transmit. So to give you an idea, what they would have done is they would have just moved it into a position, and then the engineers would have followed it, and then they can see that they followed where it needs to be. So this is all in Dutch, because of course New Amsterdam was originally Dutch.
I love that. And yes, it shows how far we've come. But it's really a reminder that